Hello students, in today's video I'm going to discuss the topic expectation of probability and stats. So from this particular branch I'm going to discuss expectation. So first of all, expectation of a random variable. So what is the meaning of this particular expectation of a random variable? So as we know, there are two types of random variables. First is x is a discrete random variable and f of x is the probability mass function. So how to calculate the expectation of x here? That is summation for x into fx. So this is all about the expectation for discrete random variable, where fx is probability mass function. If I will talk about x is a continuous random variable and f of x is a probability density function, it is just like a probability density function. So how to write the expectation of x in such a way? Minus infinite to infinite x into fx dx, where fx is what? F of x is the associated PDF. And there is one more fact here: mean is the expectation of x, or we can also write it mean for random variable is the expectation of x. So this is all about this type of definition, expectation of random variable. Thereafter, few more aspects of expectation are provided. So now I am going to discuss the next aspect of expectation. So that is known as the expectation of a function of what? A function of random variable. Expectation of a function of random variable. So again, two aspects are there. When x is a discrete random variable, and g of x is function of x. Function of x means function of this discrete random variable. So how to define expectation of g of x? That is summation x. This will be g of small x into fx, and where fx is associated probability mass function. So this is a formula here. Next aspect is here: when x is a continuous random variable, in such a way g of x is, again as we know, it is function of x. So I mean to say function of this continuous random variable. So how to define expectation of g of x? that is minus infinite to infinite. This would be g of small x into fx dx, where fx is associated probability density function. So this was one more aspect of expectation. Thereafter, one more definition of expectation is required to discuss here, that is the expectation of joint probability distribution. Expectation of joint probability distribution, so we may write it like fxy. So again we will be discussing two aspects here. Let x and y are discrete random variables. Let x and y are discrete random variables, and fxy is the joint probability mass function, PMF. So how to write expectation of a joint function gxy? Two functions, two variables are given, so two summations for x and y respectively. This will be g of xy into associated joint PMF. It is what? It is joint probability mass function. So it's like this only. Thereafter, if I'm saying x and y are two continuous random variables, these are two continuous random variables, so fxy is here joint PDF, probability density function. So how to define the expectation of g of x comma y? So two integrations, double integration we will be utilizing here, and it will be gxy into fxy dx dy, where fxy is what? This fxy is joint PDF, means joint probability density function. So this is the second formula regarding continuous random variables. Now few more deductions are required here. If in these formula, first of all I will talk about this formula as I have discussed right now. Expectation of g of xy is 2 times summation for x and y, gxy and fxy, and for this one continuous I have discussed expectation of gxy is 2 times integration of gxy fxy dx dy. So my deduction is here, let if gxy is only depending upon x, it is the only variable containing, I mean to say it is only containing the variable x. So how this will be incorporated? Expectation of x is summation x summation y, this x will be small x, and into associated joint probability mass function. I can write it summation x of x and then inside the bracket summation y for fxy. This is actually the formula for marginal distribution. So it is summation x of x into gx, where this gx is the marginal distribution of what? Marginal distribution of x. So in such a way the formula for expectation of x is different. And if for this continuous approach, again I am considering gxy is capital X, So how it will be incorporated? Expectation of x is minus infinite to infinite, minus infinite to infinite. This would be small x and into fxy dx dy. So what I will say here, I can again just extract here x separately and then inside this minus infinite to infinite fxy dy, and this is what, students, this is marginal distribution again for x. So it is minus infinite to infinite x gx dx. So this is formula of expectation of x in such a way. What if I am considering one more aspect here which I would like to discuss? For again it is extracting from the joint formula. So I want to say here, as we know, expectation of gxy is 2 times summation x and y, and this is gxy into fxy, that's it. And if I'm taking it for continuous approach, expectation gxy is what? It is just, if I'm saying, 2 times integration minus infinite to this and gxy fxy dx dy. So what it would be, let I'm considering here, suppose g of xy is only function of y. So how the things will be incorporated here? I can just write it expectation of y summation x summation y, this will be small y into fxy, or I can write it summation y and inside the bracket summation x for fxy. This is again the marginal distribution. This is again the marginal distribution. How I may write it? So it is actually summation y into hy, where this hy is known as the marginal distribution of y. So this is all about expectation of y here, and the same thing we will incorporate here. So let g of x y is equal to capital Y only. So how we can incorporate this here in this particular formula? Expectation of y is minus infinite to infinite, minus infinite to infinite small y of fxy dx dy. So it is written as minus infinite to infinite y dy and minus infinite to infinite fxy and dx. This is again the marginal distribution for y. So minus infinite to infinite y hy dy, where this hy is again the marginal distribution of what? Marginal distribution of y. So this is the expectation of y here. So in this video I have discussed few definitions of expectation. In the next video, few more aspects of expectation of random variables will be discussed. Thank you.